As a final warning as we leave probability, or simple probability rules at least, we want to give you a warning to be wary about reversing conditioning. The orders do not reverse easily. That is to say, if the probability of A given B is not equal to the probability of B given A, at least not necessarily. This is an entire branch of statistics, one that I am very interested in and that has incredibly strong medical applications. However, it lies just beyond the scope of this course. For this course, you're simply going to need to understand this concept. The orders do not reverse easily. I'm going to walk you through 2 examples to show you why that's the case, but on quizzes and exams, I'm just looking for the orders do not reverse easily and a little bit of information about what more you would need in order to answer the question. That said, the formal rule is given here. We're going to walk through an example in the next slide that should hopefully make this a little bit more clear. Let's return to our example about rain and being late. Here's the diagram we created in the tree diagram section. What we want to know now is what is the probability of it being raining outside if you are late. Note that this is the opposite of the conditional probabilities we have listed right now. This is something we can, in principle, calculate. We want to start by figuring out the probability that you are late overall. To do this, as in the last slide, we add these 2 probabilities of being late together. The probability of late and rain, the probability of late and shine, gives us 0.125, about 12.5% of the time. We also want to know, or now we want to know the probability that you are raining given that's the case. So what we're interested in is inside of these values here, how likely are we to have arrived at that given that it's raining? This means we need to take the probability that it is both late and it is raining here, divided by the probability that you are late. So 0.05 divided by 0.125. You can think about this in simplified terms as if out of 1,000 times showing up to work, you are late 125 of them. 50 of those times it will have been raining. We divide that and get 40%. Note that this is rather different than the baseline 0.25 we had before. This is all coming from Bayes' rule, and what is important to remember is that these probabilities here matter. We'll see that in a drug example in a separate video.